Hello there, everyone. My name is Christian Miles, and I'm going to be talking to you today about graphs and the police. Just a quick heads up on who I am and why I'm talking to you. So I'm Christian Miles. I'm the Technical Sales Manager for North America for Cambridge Intelligence. Now, we're a company. We were founded in 2011. We're based out of Cambridge in the UK. But myself and my colleague, Corey Lanham, are based out of North America. So Corey is down in Boston near Cambridge, and in fact, I'm based out of Cambridge near Toronto in Canada. So we're kind of a very Cambridge-centric company. Now, we have over 150 customers worldwide across a number of different verticals, and I'm really excited today to talk to you about one of those in particular. That's law enforcement. But our real strapline is definitely that we help organizations to understand connected data. And I'll be talking around that topic today on the topic of police and law enforcement. So here's our agenda for today. I'll focus first up on an introduction to kind of the approach to work with graph data or connected data. And I'll look at the data sources that law enforcement have at their disposal. I'll then finish up the presentation today with a couple of live demonstrations using some real-world data to give you an idea of exactly how graphs can be used in that domain. And then, as Corey mentioned, we will have time for Q&A right at the end. Now, a quick disclaimer. So myself, I have a technical background. I've worked as a data analyst and a consultant for some companies worldwide. And as part of that, I've been lucky enough to be working alongside agencies and intelligence agencies across the world. But I'm not a cop. I've never been a cop. I've just been, as I say, lucky and privileged to work alongside those who are working with data in the law enforcement world. So the other part of that disclaimer is that I've definitely been focused a little more on North America most recently. So a number of the things I'll talk about today will be specific to that region, but I think it's pretty clear that there's relevance worldwide. So without further ado, let's jump into our real use case here. So we're talking about connected data, and at Cambridge Intelligence, we focus on connected data. And we have a standard slide here that gives us a few bullet points on why we use graphs. But I think it's often really great to actually show rather than tell. So I wanted to show you a great example of using graphs in the real world from a recent blog post that I wrote for Cambridge Intelligence. So there was some data released by BuzzFeed detailing the connections between Donald Trump and individuals and organizations, so kind of business connections. And that was released, and Neo4j and some other companies have managed to put together either databases or visualizations of that data in a way that makes it easier to understand all the connections between Trump and his businesses. So here's the one I created using KeyLines. So this has Neo4j in the background. And this is just one example of the sort of visualization that you can create through the use of a database like Neo4j and a visualization engine like KeyLines. So what are we looking at here? Zooming in here, we see that we have a large node here. So this is a node. So this is representative of either an individual or an organization. And the node here is Donald J. Trump. So that's a person there. And he's enlarged because he's actually quite important in this network, as you might imagine. And you can see that from all of these extra lines or links showing the connection between him and the organizations and individuals he works with. Now, hovering over here, we have some events that are firing, telling us the actual roles of these links. But looking at this whole view, it's kind of a little cluttered because of how Trump is connected to all of these people and organizations. So using KeyLines, we have a whole host of interactive elements at our disposal to really help cut down the clutter in this sort of network. So I've got an option here where I can actually hide Trump. So that makes things a little clearer, and actually it's going to resize the other nodes to show us the importance of those now that Trump has kind of like a mega node has disappeared. And I can relay it out now to get rid of all those overlaps as well, now that we have a different view of our data. So here's just a great kind of one view of why graphs are a great way to look at connected data. So here we have kind of a top-down view of all of the organizations and the individuals. We see that there are a number of organizations that without Trump kind of don't really have any connections with each other. But over here, there's this big cluster here showing us all the connections and the interconnectivity between all these individuals here. This is maybe a particular point of interest for this data set. And using KeyLines as well, just finally, even with, say, Cypher and Neo4j, I can maybe even search for a person of particular interest. So let's go for this person, Trump's son-in-law. I can zoom in there and see Jared himself. And that's another way to have an interactive way of investigating the charts as it's shown on the screen. So that's my quick view of why we use graphs. Clearly, you're probably asking, this is no relevance to law enforcement. So let's jump back to our slides. But at Cambridge Intelligence, we work with a number of customers, as I say, on a number of different domains. And law enforcement is just one of those. So we get a lot of interest in the cybersecurity domain, especially in the realm of big data. But there's also some great use cases for graphs in, say, anti-fraud or infrastructure management. But as I say, today I'm definitely focusing on security and law enforcement. So when we talk about law enforcement, clearly there's data at play, and I've kind of put together this slide to give a nice breakdown of the different types of data that law enforcement can work with. And I bring these up, I've split them up into internal and external. So you can imagine internal is everything that's kind of created by the police themselves, whereas external is everything that they kind of consume from other sources. And the first thing that's apparent from this slide is that use of acronyms and initialisms aren't limited to the kind of commercial domain. Clearly, police have the same sort of lingo that they use in their day-to-day. So let's drill down into those a little further. So on the left here, for internal, I started out with maybe the most interesting to us in looking at connected data. The records management system, or the RMS system, or that's a duplication there, sorry, RMS, is just it's a real repository where the real meat of the sort of data that the police are working with is held. So if you think about the sort of data that law enforcement might have, you'd initially think of maybe crimes and individuals and officers and vehicles. That's really where all that data is stored in the RMS. Next up down the screen is computer-aided dispatch, often known as CAD. So when you make a call to maybe 999 or 911 and you report some sort of incident, that's where that sort of data is held. Also in the CAD, there's also typically vehicle information. So the police cars are tracked, and the GPS locations of those over time are shown to enable law enforcement to respond to events accordingly. And then at the bottom there, there's something else that you'd see more often in a kind of commercial context. But if you think about it, it's actually quite interesting that agencies are often being run like a business. And there's still the same sort of standard data that's generated as a result of running a business that you find in law enforcement. So whether that's payroll, scheduling, overtime, training, all that stuff is really important for either transparency to the public or just keeping track of an organization and trying to make sure that money spent, and in particular taxpayers' money, is being spent effectively. Today I'm not going to focus too much on the external side of things, but these are three really interesting data sources that are clearly quite useful in a connected data context. So license plate reader data is taken from when you're on like a highway or a motorway and maybe you see a camera. So there's typically an automated license plate reader that reads your plate and records seeing your car at that particular location at that time of day. Now this is really useful for looking around the situations of crimes in an area. So if something's occurred and somebody's noted down the license plate, you could maybe make a request to the owner of the highway or the state that owns the highway and look at the any sort of patterns for where people have either left an area or entered the area before or after the crime itself. The final two ones here are some other external data sources that are really interesting when you're looking into crime. So first up, call detail records. These are typically requested from cell phone providers or mobile phone providers, and they're just typically a very specific time range for a particular cell phone and the communications that a cell phone has had in the time range. And this is used to investigate crimes and be part of the whole investigative process. And then finally, intelligence. So this is typically the real kind of typically security classified data. And again, this is more of the sort of collateral that's generated as a result of investigation. And so crime analysts and intelligence analysts will create this sort of material that would be sometimes housed in the RMS, but often it's an external data source. Now, before I dive into showing you exactly how you would visualize this sort of data using Neo4j and KeyLines, I just want to take a little step back and think about some interesting case studies in the world today when it comes to law enforcement and their use of data. I think there's some really interesting points to be made here regarding the benefits of using this sort of extra data sources, but also the downsides and potential pitfalls for agencies using it. So first up, let's talk about social media. So police have certainly embraced social media, as this CNN headline says. So social media is a great way of tracking criminals and making sure that they being kept an eye on, especially when people are quite liberal with social media. But of course, the logical next step from that is this idea of a kind of surveillance state that we're always being watched and there's issues there. So most recently last year, a particular vendor was shut off from Facebook and Twitter because they were seen to be maybe flouting the rules or breaking the terms of service for providing that data to law enforcement agencies. So in our connected data vantage point, this is great for us looking at maybe socially connected data, so people messaging each other, and also the geolocation of where they'd be messaging each other. But there's definitely some considerations to be made when we're thinking about privacy concerns. And then my second case study is for data volumes. And we found a real uptick in the use of body-worn cameras and even dashboard cameras for police cars in North America. Here's a study from the University of Cambridge, and it's a pretty compelling headline there. Use of body-worn cameras, see complaints against police virtually vanish. It turns out when we're actually being filmed by police and we're on camera, we feel like we should be maybe have better behavior, so to speak. So there's some great studies that show that it's definitely improved the way that people interact between the police and citizens' interactions there. So then, of course, the downside of that is because they're filming all the time, there's an awful lot of data being generated. And I think this is one of those rare cases where the words big data really do apply. So we're talking about terabytes for a large agency. We're talking about terabytes in a few days, and certainly petabytes by the end of the year, for example. So then coming back to our use case of connected data using Neo4j and KeyLines, it's maybe not clear that you would use the actual video data here, but there's certainly a whole bunch of metadata that is still very, very interesting and very apparent that is certainly useful in a connected data context. So we've talked around a lot of different data sources, and your next question is certainly going to be, where is this data held in law enforcement? So clearly the title of this talk concerns graphs and police. So are police using graphs in their day-to-day? Well, typically they are using graphs, but it actually turns out that the punchline of the headline for this webinar is that they're not really using graph technologies. What they are using are some of the big names that you'll be familiar with from the commercial domain. So there we see some relational databases, very well understood, very highly optimized instances of these databases. And these are used typically as the data store for all of this data. But we see that that data is inherently connected, as I'll show you on our next slide. But even worse, depending on your point of view, here we see that we also have a number of data sources that are in Word documents or even PDFs. More often than not, external data sources are received in these sort of formats, which is not particularly scalable when it comes to retention and even searching and visualization. So the one thing I want you to take away from this talk today is certainly that the use of Neo4j and KeyLines, so Neo4j is the database, the graph database backend, and KeyLines as the visualization engine. It's a really great way to visualize this data and work with it and find compelling insights. So before I move on to actually showing you a demo today, I just want to cover why. And I don't think there's really much scope for me to go into this in detail today, but if you go to that link at the bottom left there for Neo4j, why graph databases, we have three headlines here, and there's definitely some compelling arguments there. But for the purposes of our talk, I'd like to just stress this side of the screen. So I think that using Neo4j and KeyLines or graph technologies is a great way to simplify the reasoning about data. And that should be apparent from my demonstration today. Now, things would be amiss if I didn't just give you a quick view of what KeyLines actually is. And I won't go through all of these bullet points here, but it's a really, really great way to visualize your graph data, or in fact, any sort of connected data in your backend. We have cross-browser compatibility, and we work with very, very high volumes of data. And that's what I will be showing you today in my live demonstration. So let's go back to our RMS, or our records management system. What sort of data is contained in there? So here's our first step on how we would look to visualize that data or work with it at scale. We draw together our data model. So here we have, say, an occurrence, which is typically a crime or something that's happened. And then a ticket is similar to that, so it's maybe some sort of speeding ticket or some sort of ticket issued on the street for an individual. So individuals here are shown here as a different node as well. So there's a different configuration of a node. So this is a person. And in fact, all of these other ones are what I would call entities. So we have individuals, we have phone numbers, we have addresses, vehicles, and in fact, officers, which are a particular type of individual, you could say. So a police officer, for example. So there's likely to be maybe a small agency, maybe 200 officers in the system. And they're often connected to the vast majority of all the occurrences and tickets. So looking at the links here, each of these links have roles effectively. So, individual is registered on an address, and the vehicle is registered on an address as well. And I guess most commonly and most interestingly, individuals can be listed on crimes in different ways. So just because they're connected to a crime doesn't mean that they're responsible. It just means they've been recorded as maybe a witness, or the person who reported it, or somebody at least maybe a victim of the crime as well. So the next step, once we have a view of our data, then we would likely put it into a database like Neo4j. And it's a great way to reason about your data and to look at it in this raw form. So here's just a screenshot from the Neo4j kind of GUI in the web interface. And this is just an example of the sorts of data that I just showed you on the previous screen. So here we see the red icons are crimes, The blue icons are people, and you can see all those connections kind of with this, effectively this real world data. So using this view is a great way to prototype your database and understand what you're actually storing in there. But as soon as you want some sort of consumable version of this data, you're likely to be wanting to use some sort of more powerful engine like KeyLines. So this next slide shows you exactly how that could be configured, and it's shown in this quite specific way because it's just giving you an idea of how KeyLines can be configured to match your data in a way that is kind of useful to your end users. So, for example, this is our particular occurrence of note. It's got an O in the top right because it's an occurrence. It has what we call a halo around the edge, so we're highlighting that's the one we're investigating right now. And then we have iconography here to match exactly what I'm looking at. So we have people, we have locations, and we have vehicles and the officers there as well. So this was taken from a previous blog post I wrote for the use of law enforcement with KeyLines. But I've actually drawn something together today for the presentation to show you how this would work in the real world. Now, going back to our idea of body-worn cameras and even transparency when it comes to use of social media, one of the best things for us as kind of data analysts or people interested in this sort of data is that a whole host of data is made available online in an open data initiative by a number of different agencies across the world. So here's just one example. This is the cityboston.gov website where we have all crime incidents as reported. So for the purposes of our demonstration today, unfortunately, the data underpinning this is clearly not provided to us. We're not going to get all the information about crimes and who committed them and who's responsible or who's victims. So all that information has been stripped out. But the best thing here, though, is that it is real data. We're talking about real incidents that have happened in Boston. And that's never more clearer when you look at these group codes here. So, for example, property loss, fraud, drug violation. And then we have an incident number to make sure that we know exactly these are the unique incidents that are happening. So looking at data in this view, it's fair enough. We can see what's going on there. We can maybe put some pie charts on here to get a breakdown of the offense types or the districts that we're looking at. But I want to show you how I've used KeyLines and Neo4j in the back end to visualize this in a much more compelling way. So exactly how have I loaded this data? Well, in Neo4j 3.3, there's a great piece of functionality called APOC, or I think unofficially it's known as Awesome Procedures on Cypher. Now, I warn you, this is the only slide I have today on code, but we'll just run through it quickly. Using these procedures, just load them into your instance, and there's some great documentation on the Neo website for this. We can just do a simple call against that URL that I provided from the Gov website. So we're just getting the JSON, and we're just grabbing 1,000 records for now. We then merge it and create our crimes. So we use crime incident number as the kind of the core key for our nodes there for crimes. And then we also add some extra fields that are going to be useful to us in our visualization context. We also add new nodes for descriptions, or those categories. So these are taking the offense code groups. Because we don't have the real world data, we don't have the people and the places and the officers, we're going to use a conduit for that. We're going to use descriptions to get a better view of all of the incidents that have occurred in Boston versus the types of incidents that they actually are. And then most importantly, right here at the end, we're creating a link between crimes and those descriptions. So we're saying that a crime has a description of description. So that's all a little dry. So let's jump to our actual presentation here. So going to my tab here, here's another instance of KeyLines that I've drawn up for the presentation today. Everything kind of around the edge is just kind of part of my application. So this bit here is just as I've derived for this application. But what we're looking at here is we're looking at those incidents, and we're looking at the categories of those incidents as well. So again, with KeyLines, I can run layout. So maybe I'm going to use our standard layout here just to get a better view of this. That was our lens layout before, by the way. It's a nice way of looking at it in this kind of globe format. But this is a better way for drilling into the data. And if I zoom in, you'll see that just like with the Trump data, we have categories, and we have the incidents around them, and we've got the links between them showing us the connectivity between them. Now, again, just like with the Trump data, we can cut into this and drill into it in a way that makes sense to us. So I'm interested to see here that a number of incidents actually have multiple categories. So while these over here, if I zoom in, these are often happen on their own. So counterfeiting, for example, here, these incidents don't really occur with anything else. Whereas it's nice to see here that we have missing person located and reported. We have one example where there's clearly been a person that's been found, for example, whereas these ones maybe aren't connected because we don't have the right data in this source. But then over here, there's lots of interconnectivity between these categories. So with KeyLines, I can do kind of ad hoc filtering. So I'm going to actually highlight all those categories. I'm going to filter away all the stuff we don't care to see, and I'll run a new layout on demand. And now I get a much better view of all those categories that are shown in combination with each other. So there we see better view of the incidents there versus those common categories. We're showing everything again and running a layout. We'll just see the whole screen again. Now, what we're doing here is we're actually seeing all the, as I say, all the crimes and all those categories there. But we also, from looking at our CIFAR statement from before, I did grab a whole bunch of extra data that we can use in a visualization context. Now, one of those would be to take those districts that we saw, so the kind of grouped areas in Boston for particular crime areas, and we can actually take those and use our combine nodes functionality. And what that means is we take those districts and we say, I want to put all those crimes in the same region, in the same district. I want to put them in one big bucket and show just a single node for those. So in this demo, we could turn on combine by district. It's going to bring all those together, and we're going to group down all those instances by the districts that they've taken place in. So two things to note here. Firstly, we've enlarged the combined node to give you a better view of the kind of relative size of these districts and the number of crimes that have occurred in them. And then we've also got a little, what we call a glyph in the top right, which gives you a breakdown of the number of incidents that are in this particular district. So this is all well and good. It's nice to see that we can group together and get a better idea of the different categories that we can see from a particular district. But the other thing we grabbed from the data is geospatial coordinates, so the latitude and longitude center of the district itself, or the crime itself. So what I can do is combine all those lat longs together and have a kind of single point of reference for these districts. And then using KeyLines, I can put this in a geospatial view to look at the data in a completely different sort of dimension. And there we have those grouped nodes. So we still see those little counts showing us the number of crimes that have occurred in these districts. But we put them right in the middle, or the kind of centroid of each of these districts. Now, the kind of purists on the call may think that this is not necessarily a graph visualization, and that's mostly here because we don't have any maybe address data of the individuals who've reported crimes or have committed crimes. But I think this is still, again, another compelling visualization to drill into our data. So you may be asking, of course, what are these little circles around on nodes now? So for this demo, I've turned on what we call our donuts. And these are effectively the little pie charts. And just for today, I've set these up to show us the larceny offenses. So we're looking at both larceny on a motor vehicle versus just common larceny. So this is just a theft of personal property. So some great insights we can see here immediately. So for example, in District C6, there's a much higher proportion of larceny against motor vehicles or in combination with motor vehicles than, say, for D4, where there's a much higher proportion of larceny where it's not against motor vehicles. And we can configure this to show any sort of breakdown like that we wish, but it's a great way for maybe even commanders in a law enforcement agency to understand the crimes that are being committed in areas. And using our time bar, which I'll talk about in a little bit, we can actually get a clear view of how those categories or how those proportions of crimes are changing over time. Now, I did note that we don't have any real-world data in terms of the people and the vehicles and the places that these crimes are occurring. But what I did do is I used the open source GraphGen tool online. You can look it up. I used that in combination with KeyLines to just kind of augment this data to get a better view of how this would look if you were actually a police officer working with this data in kind of the real world. So I'll just click this handy button here, add fake data. This is a kind of magic. We then add some nodes here that are a bit clearer to see. So here's a great example of us using font icons in KeyLines to get a clearer view of the data we're looking at. So now we have a top-down view of the crimes and the people and the vehicles and the phone numbers that are all related to those crimes themselves. Now, I didn't try and artificially create any sort of scenarios here, so it is all just random. So I'm not going to really stress that you can get anything too interesting from looking at this view with this fake data. But you can probably imagine, and you can probably see that looking at the whole chart here, more often than not, you would find some maybe interesting interconnectivity between people who are committing the most crimes, addresses that are reported to have the most crimes occurring at, as well as maybe vehicles being passed around, maybe gang members, for example. That's the sort of insight you can get from this sort of view. And using Neo4j, instead of maybe having a generic view where you're just looking at all crimes for a particular time period, you can maybe even run a whole query saying, you know, find me the person who's committing the most offenses in a district for a particular time period. Or maybe you could say, find me the address that is being listed as the registered address for the most people committing crimes of a particular type. Neo and KeyLines really allow you to drill into those use cases quite effectively. So just finally for my demo here today, I just want to show you this time bar view at the bottom. So this is giving us a breakdown of all the timestamps for those incidents. And it makes it even more apparent this is kind of fake data and maybe just randomly selected from the data source. But I can zoom into a particular time period, and you see there that those the occurrences that are not in that time period are being removed from the chart. And I can drill down and show myself only the stuff that's relevant to my investigation. So maybe I'm the weekly rota officer or some person in charge of distributing officers across my district. And this would be a nice way of seeing things over time and getting a clearer view of kind of patterns and trends of crimes for my particular agency. So hopefully I've given you a good glimpse today of the use of Neo4j and KeyLines for the law enforcement domain. I think there's some real great scope there for having some real empowered approaches to working with this sort of volume of data. I'm happy to take any questions. I will just jump back to my slides now. We do have one final slide I wanted to show you here. If you are interested in looking at KeyLines in any more detail, you want to try it out either with your law enforcement data or you've seen something today that's maybe relevant to your domain, please go to that link above or just contact me directly. I'll be happy to help you out with a trial, or if you're elsewhere in the world, I can direct you to the right person for that. But we can give you a trial. We do offer free trials and no obligations, so you can try KeyLines out today. But there's also a link there for Neo4j. They have a great web presence. Check out their website. There's a sandbox section on their site that's really great for without having to download anything. You can start working with graph databases. But I'd just like to say thank you once more for Neo4j for the time today.